This video is about finding the domain of operations with functions. So we're going to be adding functions, subtracting, multiplying, and then dividing the functions. But what we're not interested in is what they become. We're interested in what their domain is. So we have two functions here that we are adding, subtracting, multiplying, and dividing. And what we're looking at here is a domain of each before we start. So we're going to start with f of x and find out what its domain is. So if you remember with radicals, whatever is inside the radical, this has to be positive. So we say that x minus 3 must be greater than or equal to 0, because it can also be 0. And then solving it, we get x is greater than or equal to 3. So what we're going to do now is put that on our graph. 3 would be like here. I'm thinking of 0 in the middle. 3 is here. We put a bracket and we shade. And so what these are is they are basically and statements. We're looking at the intersection. So when we add each of these, so that's not f now, that's g. We now look at g of x. When we add, subtract, multiply, or divide these, we're doing an and statement. We're trying to see out where are the points that we can plug into both of them. So same idea, x plus 4 must be greater than or equal to 0. So x must be greater than or equal to negative 4. So that would be over here. And it's greater than. So we're looking for the intersection of both. So because what's happening is if you take these two functions and we're going to plug them in, so f of x plus g of x is now our red, we are getting square root of x minus 3 plus square root of x plus 4. And to input a number, like if we just pick a number like we know 0, it fails here. This is going to become a square root of negative 3, which is not real. So it's not going to work. You can't plug in 0. So nothing over here is going to work in the blue one, into our f of x. So this is our f of x, and this is our g of x, and we need two numbers that we can plug into both. So we can't plug anything in here until here. So right here is our intersection point. So that is the domain of our two functions being added together. And it doesn't matter if you subtract them, multiply them, or even divide them. It has to be able to plug into both functions. So I've already plugged this in Desmos to give you a picture of what it looks like. So we have our f of x, our g of x. You can see the g is in blue, the f is in black, and then the add, subtract, multiply, and divide. And if you look at them, they are all starting at 3. Right here, they all start at 3. They are all getting bigger than 3, and that's why our domain for all of them is x is bigger than 3. So it's from 3 to infinity. Now the reason I have down here our f of x and g of x separate is if our g of x is a denominator, then we would get f of x over g of x is equal to, our f of x is the square root of x minus 3 over the square root of x plus 4. So the same domains still apply. This is x is greater than or equal to 3, and this would be x is greater than or equal to negative 4. However, this denominator, this x plus 4, is now a denominator, and denominators cannot equal 0. So that means x cannot equal negative 4. So how we take care of that is you just go over to that little inequality and you get rid of that equal sign, and it just becomes greater than. So how does that look graphically? So the top doesn't change. It's still greater than 3. But the bottom now, it changes to a parenthesis. And that becomes negative 4 with a parenthesis. Now it didn't affect anything here. This still goes from 3 to infinity because that not equal to over here is not actually included in our domain to begin with. So of all our graphs, they look the same. They all start at 3, no matter what, because this negative 4 here, even though it cannot equal it here, see x cannot be negative 4 here, it won't affect anything. However, now let's switch it. So if we flip these upside down, now the f of x is on the bottom, and look what happens. And so our f of x is greater than 3. It's this graph. And so now we can't actually equal 3 here because our f is a denominator of 3. And so if you follow this up, see, it's never going to hit it. It's never going to hit 3. It's going to get close to it and closer to it, but it'll never actually hit 3. So this bracket here is turning into a parenthesis. So how does that look? So it looks like this. If we take g now and divide it by f, this switches our function to square root of x plus 4 over the square root of x minus 3. So this is still x is bigger than or equal to negative 4. This is still x is bigger than or equal to 3. But since it's a denominator, we get rid of that. And so now if we look at it graphically, this would be the same, except the top one now is a parenthesis. The bottom one, the 4, is still negative 4. And so the domain now changes. It becomes 3 on. And so it becomes a 3, infinity. So our domain for all of these, for f plus, f minus, f times, and f divided by g, are all bracket 3 to infinity. But the one, f divided by, or sorry, g divided by f of x, its domain is 3 to infinity. So these are all bracket 3 to infinity, but by putting this x minus 3 as a denominator, it turns that bracket to a parenthesis, meaning it cannot equal 3. So if you graph those functions as you add or subtract them, it will tell you the domain. See, you can see the domain here on every single one. It goes through each one. And if I change that to a negative and plus, look, we get this crazy thing. So now it's between negative 4 and 3. That's our domain, negative 4 to 3, except for this one. Look at it. See how it goes off to infinity? That's when 4 cannot be equal to it. So this one, our f divided by g, g is now a denominator, so it can't equal 4. Pretty cool. And look at this one right there. See, can't equal 3 going the other way. So graph them, look at them, but you're just using the domain of each to figure out what the answer is. You want to graph each one individually, find out their intersection, and that is your domain. Graph them each individually, find out their domain, and then plug it in the calculator and it should match.